get started with the digitalization panel. Thank you, Eugenie, for being a sponsor and for supporting the forum. And also, this is an interesting panel because we have our clients with us, so CNG and ResFrac, so thank you for supporting us as well. So hopefully we get many more such panels in the future where we have clients and sponsors all together on the podium. So I'll get started with the insights that we have gathered based on our research. I'm not going to touch a lot on upstream because we have our speakers who will talk about that. But overall, what we have learned from our work in digital in oil and gas is that for oil and gas companies, digitalization is going to be incorporated over a broad range of capabilities and initiatives. In our experience, we have seen that there could be at any level from just mere data collection and virtual interface all the way to real-time monitoring or much more complicated analytics in the real time. To be successful in adopting digital, operators will have to take small steps going from the very simpler applications all the way to the combinational analytics as they grow more comfortable with these technologies. Why I say this is because that one of the key constraints that we have come across in adopting digital is data security. A lot of the operators that we talk to are not even sure about the value proposition. And also the whole idea of having to adapt to new technology and undergoing training to use these tools effectively are some of the key constraints that we have seen. Also, when we look at adoption of various digital offerings, we see that process automation, drones for monitoring, condition monitoring, as well as predictive maintenance are some of the key areas where we've seen value being added. So this is a case study of where ADI, we profiled a tool that essentially tracks the vibrations of a small equipment in a refinery. Now, we've already seen such monitoring tools already being used for large equipment, but as smaller equipment are not deemed more expensive to replace, they're not being used to monitor actively as a large equipment. But if we talk about, say, pumps that feed into FCC units, or if we talk about injection pumps, this could be less expensive to replace, but still, if we talk about the downtime and compare it with predictive maintenance, the downtime can really be as cost intensive as a large equipment failing. So we do see that there is large players such as Honeywell, Emerson, ABB, who have developed tools and technologies to address this. And if we see that, not even considering the slowdown during COVID, but if we look at the estimated market size for such a tool, we see that through 2025, there could be a 70% growth annually that can be realized in the market. So we see that there's a lot of technology already employed when we talk about equipment monitoring. But we see that it's almost 2/3 of the value proposition that has still not been realized is by process automation, and that's what we see the next step for downstream digital will look like. So talking about some of the downstream examples, we see that Borealis is using machine learning and analytics to predict compression failure. Similarly, Air Liquide is another company that's using digital for predictive, preventive maintenance and optimizing their operations. Nutrien has developed a tool for farmers where they can pick what outcomes they would like and what seed they would are likely to get that outcome from, which can minimize their store visits and help them make right decisions. And then Tech Metals, again, uses data-driven AI to predict equipment failures. So moving on to the panel, we have, like I mentioned, we have the panel here is active in upstream oil and gas, so that's why we'll leave the insights on upstream on them. So thank you. So we have Soudip with Eugenie, Sheldon with CNG, and Rohan with ResFrac with us. So it will be helpful if we can just, with a quick introduction about yourself and the company.
Thank you. Thank you, everyone. Hope you can hear me.
Yes.
My name is Soudip. I'm the founder CEO of Eugenie AI. So we are helping asset-heavy manufacturing, including oil and gas, to help them track, trace, and reduce emissions via process and asset level optimizations. So the previous panel spoke about how do you find out opportunities where uptime as well as reductions of emissions can be achieved together. So one of the pioneer platform for that, achieving that using our digital twins platform. So happy to be here and talk more about how we do it.
Hi there. Thank you. So Computer Modeling Group's got a long history, over 45 years, Calgary-based, traded on the Toronto Stock Exchange, started as a research consortium way back when, been a publicly traded company for a long time. We're a successful software company focused primarily on reservoir simulation software. And so certainly we've branched out from that in recent years, and just this year we made the company's first acquisitions. One was a tuck-in acquisition focused around shale plays and using AI technology backed up by physics to improve well recovery. And the other one was a seismic interpretation software company out of Houston called Blueware. And so our focus is primarily subsurface activities, not completely. We also have an integrated asset modeling tool. But we're focused on helping our clients reduce risk and be more efficient in how they work. And we make use of AI technology to help us do that.
All right, thanks, Sheldon. Good morning, folks. It's great to be here. Also mindful that we're between you and lunch, so hopefully we'll keep this interesting and engaging. I'm Rohan Irvin with ResFrac. ResFrac's a software company somewhat similar to CMG, though on the newer end of the spectrum. Our primary software product was launched commercially in 2018 and is the industry's only fully integrated hydraulic fracture simulator with a reservoir simulator, also with a commercial engine as well. And what this allows our customers to do is to run thousands of tests before in the model before they go out and try them in the field. But as a wise man once said, all models are wrong, but some models are useful. And I think it's important as we sort of talk about anything that we're using models for, it's important to bring it back to what's the value of these models. And it reminds me of a conversation I had with a customer recently who was working on a particularly challenging project that was dragging on and behind schedule and challenging all of those involved. And when I asked him why he kept pushing forward with this, why they were sticking with it, he said, if we figure this out, it's worth $1 billion to us. So that's the sort of value that we're looking at here. And I think that's reflected in ResFrac's growth in its short time frame. We're now working with 7 of the top 10 US oil and gas producers, growing at about 80% per annum. And I think a lot of that is tied to what Will brought up in the previous panel, which is we're moving away from the core areas. A lot of that low-hanging fruit's been picked. We're starting to move to these tier 2 areas where we have to be more intentional about how we're deploying capital so we can be more efficient and more effective with that capital.
So like you mentioned, Rohan, ResFrac has been working a lot with the shale operators. So in your view, what are the key trends and what are the shale operators doing?
I think tied to that point I just made, that we're moving away from the core areas. We're seeing more of an emphasis on optimizing things like cluster spacing, well spacing, proppant loading, and the realization that the optimal design parameters for some of these developments are not, they vary quite a bit, not just on the rock, but also on the commodity environment. So, your optimal well spacing will be a function of your oil price. And then your optimal proppant loading is going to be a function of your optimal well spacing. So everything's kind of tied together. I think we're seeing that as one of the key trends, in that we've got to think beyond just using data analytics based on what we've done in the past. And so we've got to use these physics-based models to investigate options available to us that are outside of our past experience.
That's helpful. Sheldon, CNG works with the operators across the asset types, from offshore, deep water, all the way to a lot of energy transition. What trends do you see there, and how do you see the market is, making decisions there?
I think it certainly depends on the asset type. If you go to shale, I would echo what Rohan said, and I've been one of these people waving the flag that so many shale operators, not just in the U.S. and Canada as well, which is where I'm originally from. The completion engineering being done was via photocopier. Well, what did I do last time? Well, what did the neighbor across the next lease do? That's what we're going to do. And they might get a great well, but they don't know if they got the best well they could have. So it's nice to see that some of that's changing, although, maybe out of necessity. But, that's one of the trends. You go to offshore and deep water work in particular. There's a lot of trends specific around the seismic side. The amount of data that geophysicists have to contend with now means you have to use new technology, not just cloud-based technology, but you have to be able to move, visualize, interpret your data more accurately and much more quickly than in the past. Specifically for CCS activities, it's new. And we've been in that space for over 20 years, but the industry is learning so much. Ourselves, our clients, our competitors, regulators. We work with most of the regulators in the U.S. and so they're just catching up along with the rest of us on what's needed. Our clients' models are huge now, and not for all clients. Whether they're just doing a scoping project or getting a little more refined in their data, they're encountering challenges with geochemistry, geomechanical issues. What rate do we inject our CO2 at? We've got to model the plume for 1,000 years or more, and what sort of fault reactivation issues are we going to have, and how does that tie back to how we interpret our seismic and where those faults are, and how do we model that? So it all depends on the asset, but a number of trends. The amount of data and how we use that data is probably, I think, where the greatest focus is on some of the trends we're seeing with technology.
So Soudip, Eugenie works across the oil and gas value chain. So where do you see the acute needs for digital twins or for AI?
Well, my answer is like looking at your research, right? So what analysis, I think you pretty much captured the need that we are also seeing in the market. Across the value chain, the biggest need at this point in time is how do I get better data about my operations so that I can go back to the regulator, because there are a lot of compliance issues all of a sudden that most of the operators are not feeling comfortable with. But how do I, get back to them, whether it's talking about Quad O or California newer disclosure bills. And with this new kind of data, how do I go back to them and show them a better audit trail of my operations? So that's the reason why we see more and more interest around real-time data capturing and analysis. And while I'm doing all these projects, how do I reuse this data in order to improve my operations, top line, like production increase, optimize my process so that I can produce better output out of it. So all of these are kind of seeing whether it's upstream operations, pneumatic controllers or compressor optimizations, which is leading them for emissions and or production losses, to downstream operations across the value chain. We're seeing the same trend, and thanks to like what today we're seeing in change is the emergence of newer technology like AI, like data technology, like we're using satellite to whatnot, right? To get better data provenance for any insight. It's not that you got to depend on only data coming from your physics-based analysis or only from sensor data. There are other data that you can bring to the table so that you can build more strong data dictionary, which you can either use for your product lifecycle assessment, whether you use better understanding of what is going wrong, root cause analysis, figuring out where exactly you have to focus on in your operations that can improve your quality, yield, production, at the same time emissions. So those kind of trends that we're seeing, and kind of Eugenie helping our customers in all of these places with our platform. So we bring optimizations, having different outputs, bringing together on the same fold, and doing, using the best-in-class AI, whether reinforcement learning or multi-objective optimization to optimize all of this together. So it doesn't look like, oh, I have to run an emission reduction projects. So the emission reduction projects become an offshoot of your production improvement project. So that's where we are seeing more and more interest in the current, industry. Yeah.
So Sheldon mentioned seismic. So one thing that we know that seismic has a lot of signal to noise, so is that something that you see in emissions technology as well, and how do you address that?
That's a great question, and that's the reason why I mentioned previously why use bottom-up data and top-down data. Of course, from satellite you can detect methane detections up to a certain level of certainty. Wind speed, and you can model all of this, and to understand what exactly the volumetric, the volume of emissions as well as the composition of it, using the infrared image that today we subscribe to all different satellite channels. So that's a top-down view, but that's not enough because there is a lot of uncertainty as well. There is a cloud coverage and whatnot. So then you also need some other additional data like bottom-up data for sensors which are fitted on your machines and whatnot, right? So from there you kind of try to understand the attribution of that overall emissions from individual process and machine level. And then on top of that, that's also not enough. What if the sensor is not reliable most often? So then you also need to augment that with physics in order to understand, what is the emission factors of that particular machines. So combining all of this together we are seeing that the actual value that is bringing to the table, like, how do you reduce the signal to noise ratio, combining all these different data.
Okay, that's helpful. So. So one question I have, Rohan, for you is that when we talk about ResFrac, and you mentioned some of the value proposition based on the latest difficult project that you had, but on a more wider level, like less specific, what is the value proposition that operators see with an offering such as ResFrac?
Yeah, I think it comes back to that intentionally deploying capital in the most efficient and effective way. I mean, we talked in the last panel, we heard a lot about the M&A activity and how companies are consolidating positions in basins. Pioneer is a very big client of ours. And as Exxon picks up their acreage and looks at the running room they've got in the Midland Basin, for example, picking up a bunch of pioneers, undeveloped acreage. They are a very return on capital employed focused company, Exxon, and so they'll want to run simulations to ensure that they are deploying that capital to maximize the return on that capital that they're employing. In a physics-based model where you've got the capability to fully integrate it with an economics engine, you can run an optimization and say, well, if our objective is return on capital employed, what's the optimal design parameters for the next 10,000 acres that we're going to develop? And that answer might be very different to if you're a very acreage constrained smaller company where you might want to be optimizing MPV per section, for example. So the value proposition for our customers is that they're able to make informed decisions to reduce or increase the likelihood of success of their field trials going forward, and make sure that those design decisions are informed by the priorities of that organization.
So, Rohan, one follow-up question I had to that is that I read about a trend where there's a lot of refrac going on, and as we know that a lot of shale acreages, as you mentioned, are maturing. So, do you see that to be a real trend, where companies are refracturing, and would those parameters for optimization would be any different than what we are seeing historically?
Absolutely. So, particularly in the Eagle Ford, I think Will mentioned that in the last session. Refracs, there's a bunch of opportunity there. We also see it in the Bakken as well. It's not really a recent trend, but there was a trend over the past, say, 10 years ago up to maybe 8 years ago, where cluster spacings were quite wide initially in many of these basins we developed, and far from optimal. So that's really one of the fundamental reasons behind why refracs are attractive. But then looking at when we're trying to decide what's a good candidate, we've really got to take into account the coupled nature of geomechanics and fluid flow. As you deplete that parent well, the pressure reduces in the formation. You're changing the stress state of the rock, and so your completion of that refrac is going to be very different than a completion of a neighbouring child well.
Okay, that's helpful. So, Sheldon, like you mentioned, CMG recently acquired Blueware, and there's a large component of AI and ML in that technology. So, how do you see the future for such technology in upstream oil and gas? And do you see more of that in energy transition as well?
Yes, completely across the board, whether you're talking about subsurface data, surface data, energy transition, geophysical, reservoir engineering data, absolutely we'll see more of that. One of the areas we focus on specifically around AI and ML is ensuring that, and our geophysicists like to remind people that we're scientists, we're not computers. And one of the challenges, if you look at our interactive AI tool, there are tools out there, and we face this with a number of customers when we talk to them about our AI technology for reservoir engineering as well. There's a core number of clients globally who still don't trust it. They look at it as a black box. So that's why we focus on that comment that geophysicists and our reservoir engineers make, is that let's remove that black box from there. Let's make everything we do physics-based, and let's make sure that the individual user has got input into the results and can understand it. So specifically around our seismic interpretation tool, Interactive AI, we look at, from a data-centric point of view, the interpretation we work and do with the tool rather than a model-centric approach. So if you think of a model-centric approach, it's very much like a black box. You've established a base of results from a model that may or may not be applicable. You're making assumptions that everything you're doing subsurface is homogeneous, at least to the point of your previous model, and you're trying to apply it across what you're looking at today. And the results can be as simple as, and I call it simple, it's not, but the amount of capital invested. If you mess up a well in the Permian, millions of dollars. But what happens if you do that deep water Gulf and you mischaracterize the fault or some other geologic feature? You're talking over $100 million issue potentially. And so geophysicists will go in, identify a structure, and in real time or near real time, their prediction is completely updated. So rather than relying on what the model tells them from an AI perspective that they should see, it's updating it, and they're providing that input as they move along. And not only is it more efficient, it's far more accurate, especially when we're talking about even larger volumes of data that we deal with deep water Gulf. And so we're going to continue seeing that growing. And we're winning our clients over who are afraid of the black box approach to this, and I'm sure my peers on the panel here have faced that with clients as well. And so we'll continue to see growth in the AI world. And this is, I'm full of analogs that are completely inaccurate, as people who get to know me realize, but you know, we're all familiar with ChatGPT and what it does, and I call what most people are familiar with consumer-grade AI. And so they assume it's the same. You just paint a brush across everything we do too in the industrial world. And it's not the same, right? And nor should we be applying it like that. If you take something as simple as, say, history matching, and you apply it, and I've seen really good examples of this from a client, see that applied with, call it consumer-grade AI, the results are completely different than from what we would do from our perspective, right? And so, you know, not only remove the black box approach and that fear, but the results are far more accurate for the user.
That's helpful, Sheldon. Thank you. So, Soudip, Eugenie seems to have a wide range of applications. Where do you see the most value proposition that your tools can bring?
I think one of the things Sheldon just mentioned about unraveling the black box and make it a white glass box AI, I think where we are seeing the maximum interest, like what we have behind the scene is the traceability, and that's why overlaying top-down data view, and then bottom-up, and and then combining that with physics along with human in the loop, so that bringing all this together consistently is the innovation, right? How do you bring it, like, without overplaying any of this aspect, and still, there are decisions at the end of the day you are enabling, in this case, operators to make, and they not essentially trusting or believing in what you are showing. They might have their own questions in their mind. So how do you give them enough evidence, enough data points for them to make better decisions faster way? And at the end of the day, improving the productivity, improving the speed at which they can make decisions, and better decisions that can improve both operational efficiency as well as sustainability. So that's where we're focusing on anyway. But where we're seeing newer interest is because there are a lot of noise about both AI and about emission regulations. And that's why, like, say, for example, as you rightly mentioned, we work across different types of clients, not only only with oil and gas clients. So just to give an example, we are working with one of the biggest data center company in the world, and their scope 3 coming from oil and gas. So now they want to mobilize their capital to reduce oil and gas, like their suppliers' emissions, and they are willing to fund the project, because otherwise they are purchasing today voluntary carbon offset from public market at $60 per tons of credit. Now that's not also good credits, and a lot of public perceptions around it. So they want to make sure that they are investing in good projects where actually they are reducing scope 1 and 2 for their suppliers, and eventually they can get credits out of it. So these are newer types of innovation that are coming with the ecosystem. It's getting more very interesting in this space. And across the value chain, we are seeing that this is a kind of newer trend. AI and climate both coming into the picture, and giving the whole space a little bit more air.
That's an interesting perspective. So, Rohan, ResFrac has been helping geothermal projects as well. So can you give us a little bit of an insight on how geothermal market is evolving and what are the trends there?
Absolutely. Yeah, it's a really exciting time in geothermal for those who haven't been familiar with what's happened in the last 6 to 12 months. It's sort of analogous to 2010, 2011 in the shale boom. Fervo Energy proved a lot of naysayers wrong in the last 12 months by drilling faster than through hot granite rocks than was ever thought possible, by connecting these wells up with hydraulic fractures, and are now producing commercial energy for Google in one of their projects, and rapidly growing. They've also raised a lot of money to continue that growth, and so we're friends of Fervo and have they've been using ResFrac software since their inception. And actually last week I was out at the Stanford Geothermal Workshop in Palo Alto, and Fervo's CTO made the comment to someone else in a side conversation at a happy hour that they wouldn't exist without ResFrac, which I thought was very, very kind words. I'm sure they would have found another way, but they were able to use our software to prove to their investors that this was possible, and then go into the field and demonstrate it. And I think that's a great case study for the value of physics-based models.
So do you see geothermal, like more interest from players such as Fervo because I think Devon recently also invested in them. So do you see like a larger push from operators into geothermal? Yeah,
Devon was there at the Stanford Geothermal Workshop last week, as was probably half of the main oil and gas operators in the US, which was a surprise to all the geothermal folks. The interest from the oil and gas industry is growing, and there were folks there from Shell, Chevron, Exxon, a lot of the top players, BP. So we're definitely seeing a growing interest. There's not enough companies following in Fervo's footsteps just yet. I think we'll see that change in the next 12 months, and if anyone's thinking of starting a geothermal company, I think now's a good time and go after it, because it's going to be a really valuable contribution to the energy mix, particularly in the US going forward.
And I think Rohan is here till at least for some time, so you can help the way you helped Fervo if anybody was interested.
Yeah.
Yeah. So Sheldon, Blueware has also been helping offshore wind industry for some time now. So can you give us a little bit of more insight into that, and how do you see offshore wind going forward?
Yeah, so we participate in lots of different energy transition technologies and energy sources, and wind is one of those. And so we've been working with the largest Norwegian power producer, and the challenges with seismic data are different, obviously, than in a traditional offshore oil and gas project. Offshore oil and gas, you've got, maybe you're going through 10, 20,000, whatever feet of seismic data. And far less than that with wind. You're looking at seabed scans, you're looking at, from a volume perspective, it's fewer feet, but the amount of data within that is much higher density. And so you're looking for not just hazards on the seafloor, whether those are historical communication lines, pipelines, etc., but dealing with natural, topographical, and geological subsurface hazards that are near the surface. So the volume of data is tremendous, and that's what we have a volume data store tool that we use that helps clients not just visualize, but move, store, and make use of massive quantities of seismic data. And without that, wind companies would certainly take a lot longer to get their work done. I remember the old, and I shouldn't say this, but the old days working with seismic data, and you'd take up so much computer memory, download everything, your entire model, and every time you made a change or rotated it, you'd wait for it to be refreshed, right? Mm-hmm. So that's not a challenge that they have anymore.
That's helpful. So, Soudip, what do you see are the most low-hanging fruit for Eugenie's technology, like in the near term? Because a lot of energy transition is very long-term focused. So what do you see the opportunity in the shorter term?
I think the shorter term is optimization of processes and assets, right? For an operators, right? It is like, when the policies will come, we'll see then. Well, you can, wait and watch, or today, sometime it's going to come, right? That's for sure, it's coming. It's just like whether it's 2025 or 2026, the question is when. But meanwhile, the project like Eugenie is not only, as I said before, it's not only your capex intensive projects like where I'm decarbonizing, changing everything to hydrogen, but it's like, how do I run my existing operations more optimally with the help of AI and the help of data that can not only reduce my emission but also improve my efficiency. So that's the low-hanging for a company to prove the ROI in shorter term than just doing a long-term capex intensive projects. And that's exactly where we're seeing more of tech in terms of people are willing to work with us because of the fact that they're definitely working on solar projects, they're working on other projects of energy transition. Well, Eugenie is existing operations, how do I improve, thereby I can reduce 10 to 15% of my existing operations, whether it's fugitive or process emissions on a month-on-month basis. And that result we have already delivered across industry, including oil and gas upstream. Yeah.
That's helpful. So I'll, give the audience a chance if there are any questions.
Thanks. Maybe a little off topic, but it was quite interesting to listen to this geothermal breakthrough technology. So can you elaborate a little bit what is being produced? Is it steam that's coming out of the geothermal process, or what is it? And what level steam are we looking at?
Sure. So what they're doing that's new is extracting a thermal resource from granite, basically rock that has very, very low permeability. And so they're doing that by drilling a pair, just as a very simple example, a pair of horizontal wells, completing them with hydraulic fractures to connect the two wells. And then they'll inject cold water into one well, and hot water and steam comes out of the other well. They're typically going for 400 degree F formations. So you've got a mixed phase coming up at the wellhead of the producer. But these are areas that they've targeted so far. They're areas that are nearby existing geothermal power generation areas that are hotter, but have not been able to be exploited to date because of it's granite, not a permeable sandstone.
Thanks for this enlightening discussion. As Panuswee raised an important question regarding the enhanced geothermal system, I would like to learn your perspective on this evolving, geological hydrogen exploration. They are also doing a lot of analysis using AI digitization tools. So what is your perspective on that?
Sorry, who are you directing the question at?
Anyone is welcome.
I think there's bigger challenges with the hydrogen industry, and not that it's not going to be successful. I'm not trying to say that at all, but just everything from infrastructure to how it's going to be used, the energy, and perception. Right now, the perception is through the roof on hydrogen resources, on what companies are going to do and are doing to extract it. So I think that there's bigger challenges there. As far as AI technology goes, I would say, and I can speak from CMG and Blue Air's perspective, the AI technology that we apply to the resources we're working with today would apply just as well to hydrogen. There'd be very little difference from that perspective. Now, if you're talking from the resource, any geochemical issues, that's where there'd be some slight changes, and we have compositional models that model that today, so no change from that perspective.
I'll add to that in that the challenge faced by the geological hydrogen exploration industry is that we've got, one of the opportunities is that we've got a wealth of data from oil and gas exploration, 100 years of oil and gas exploration. The challenge is that it was focused on oil and gas, not on hydrogen. I've personally experienced working on an exploration play where there was evidence of hydrogen in reports from, say, the 50s or 60s, but whether you can trust it or not, So I think it was the challenge measurement. Accuracy back then was not as good. And so one of the opportunities for AI is probably to efficiently sift through mountains of grainy PDFs from the 1950s or earlier to identify or shortlist candidates for humans to then look at.
Hello, thank you for the panel. This question is, again, for the whole panel. What are the main difference in digitalization when we look at oil-producing third world countries like Brazil or Angola, and then when we look at the US? Is there any main difference, or?
Okay, sorry, can you repeat the start of that question?
What are the main difference in digitalization when we look to third world countries that produce a lot of oil, like Brazil or Angola, to the US, for example?
Quite often you'll see technologies adapted here first, but that's not always the case. I was in Brazil this past summer and I shouldn't have been, but Petrobras is a very large client of ours and has been for years. But I was pleasantly surprised at how far along they were on the use of technology for carbon capture and storage. And their scientists and their ability to understand the complexities subsurface of what was going on and the geochemical and geomechanical issues they were going to have for the next decade exceeded most of the clients we had spoken to. So it really depends on the country. Sometimes some of the areas around energy transition are driven by the regulators first before companies get interested, outside of places like North America. There are always challenges in adopting new technologies, but they're going to come back to the same questions that our clients here will have, and that's, well, what's the return on investment for me going to be? Are you there? Are you reducing my risk potentially, right? And that's where there's some subtle differences. On that same trip, I talked to a client whose neighboring producer had some fluids to surface, and as a result, their own offshore platform had to be shut down for a full year. Not because of anything they did wrong, but something their neighbor did wrong. And so the concerns were not taken quite as seriously at the time. Obviously, that's changing within that country and the regulations in that coming from the government. It depends on the country, though. But oil and gas producers the world over are trying to implement new technologies, and this is something we all need to wear. We're not quick to implement new technologies in this industry. We might think we are, we're not. It's getting better, thankfully, but I've been through lots of cycles of technology innovation, whether we're talking about real-time aspects, data analytics, now AI. We take a little longer than maybe we should in our industry, right? So, and that's true globally.
I'll just add to that. I completely agree on the fact it's not from country to country. In my experience, I think company to company. Like if your innovation is your DNA, so you will do it no matter where you are. So there is a practical limitations in terms of data readiness. Like few companies does not have data. They want to, but they don't have data backbone. So that requires a lot more investment and seriousness from CXO level and top down. Oftentimes there where you see a little bit of you got to do a lot of evangelization. So you got to work, like for example, our main job is to work with the CIOs to evangelize, thereby the CXO buys that and then push it down, right? So in that way. Things are changing. Obviously, wherever you have compliance issue, it's like it's coming from CFO and you cannot help it, right? So you just have to do it. But otherwise, it's depending upon the DNA of the company. It doesn't matter whether you are based in Middle East, in Africa, or in the US. It's the same. Like you want to innovate, and you are reading anyway. AI is changing the world. You have the FOMO, like I'm missing out something, so I need to do something about it. I need to digitize. I need to do something. Otherwise, my competitor will eat my business. So that's how it is.
There is one thing I'd add to that, and that's around data residency. There's some regions of the world where they're required to keep the data within the country. And so if we're trying to get a client to work with us on the cloud with Azure or AWS, presents some unique challenges, but then we've got partners in those cloud providers who are setting up cloud instances in country, and that helps a lot, right? So a lot of the challenges are related to data, as my peer here mentioned.
Yeah.
Thank you. Thank you. Very good points. Having been on the other side of the software vendors, I have to say that, and being in digital for 20 years now myself, I think the adoption, and correct me if I'm wrong, you admit that some companies do it, some countries do it better. From my perspective, and I'd like to hear yours, I think it's the delivery of the message of impact that's maybe could become clearer from the salesperson's perspective or from the presenter's perspective, because I think digital's massive and it's been adopted massively, and I don't think there's really slow. I think the expression of its impact might come across better.
Yeah. No, I agree.
Instead of the intangible uptime, decision-making, intangible values. I think we all get that, but I want the tangible coming across from the decision. Because why are we even asking that question? We're all digital.
Yeah.
The so what, right? And that's
so what.
You're speaking right to my heart when I talk to team members about that, right?
Yeah,
so
but you're the CEO. You don't go to your clients.
Tell the client the so what, right? And that's what they want to hear.
Yeah, but I want to know what my impact is if I buy from you.
Yeah. So I think the digital sellers, they are coming from tech, they want to sell tech. That's why they fall short of it. They want to sell value. So the moment we start selling values, probably we'll see a different picture. So things are changing, obviously. Value in terms of top line, bottom line, both are values. Though I don't agree with the fact that decision-making speed is not tangible. It is tangible. Like how quickly you're making decisions. Say, for example, today with us, people are making 60% more. So we could measure that. That technology can provide, like, how fast those decisions have been made before and after. You have A/B testing done.
Yeah, but a fast decision doesn't mean more money.
And better decisions. It's not only fast, but better means that is impacting where.
But
like
what's
your
that
top
better
line.
decision? A percentage of money or a percentage of risk?
Savings.
That's what I want to hear.
Yeah.
I'm not hearing that.
Yeah.
Okay, I think this is a good point, and I think there's a lot to discuss on it. But for the panel, I think we will wrap the panel up now, and we can discuss more offline. But before I wrap up and we break for lunch, we have 4 terrific panels coming up: oil field services, gas and LNG, midstream, and refining. So. See you all after a little fueling up.
Thank you.
Thank you.
Thank you.